Okay, everybody, we're going to be continuing with our filtration. I'd like you to take a look and see what we have right now. I just kind of filtered a little bit without keeping your attention to it because it can get quite boring, but I wanted you to see. This is my filtrate. As you can see, it's blue because it still has copper in it, but it is fairly clear, meaning I'm able to catch my precipitate on the filter paper. And now we're going to zoom in into the funnel so you can take a look and see the blue solution that I added prior to this has pretty much all dripped down, but you can see the white precipitate hopefully on the walls, not on the walls but on the filter paper. This is our barium sulfate that we're trying to collect. I'm going to pour some more in. And you can see it's dripping down. And the key here to make it go faster is to keep adding a little bit of the mixture into the funnel. As soon as some of it does drip down, this increases the pressure of the liquid inside the funnel and pushes the liquid through the filter paper faster. Typically, when you are finishing the filtration like this, it does tend to slow down because the precipitate now is clogging up the paper, which does slow it down a bit. I'd like you to take a look at this beaker here. You can probably see that there is a lot of white precipitate still left, even after I added everything here. So what I'm going to do is I'm going to use a little bit of dry water to sort of wash down the walls and the bottom of the beaker. And then I'm going to swirl it around to make sure my water that I added does pick up the solid. And I'm going to quickly add it to the funnel to ensure that most of the precipitate went down with it. And I'm going to do this one more time real quick. So a little bit of water. Swirling it around, making sure the precipitate gets into that water, and then quickly pour it down. Now, right now, the beaker appears to be pretty much clean of the white precipitate, but in case if I still have any of the precipitate left in the beaker, I'm going to use this simple device called rubber policeman. Funny name, I'm not sure where it comes from. But I'm going to take this rubber policeman. It's basically a rubber squeegee attached to a glass stirring rod. I'm going to wipe the inside of the beaker really well, getting the walls and the bottom like this and like this. What I'm trying to do is try to collect any barium sulfate particles so they get stuck to the squeegee, to the policeman. The way this works is rubber is electric insulator, and having the policeman wipe the beaker, barium sulfate consists of ions. Ions are charged, and so they get attracted to the rubber. So now that I wiped my beaker with the policeman, remember that little piece of filter paper, the corner, I told you would be tearing off and saving, so that's that piece of filter paper. I'm going to wipe the policeman on all sides with it, collecting any barium sulfate which otherwise would have been left behind, and I'm going to put the paper in here. This is a simple trick that would allow us to collect as much precipitate as possible. So now that filtration is pretty much over, as you can see, all of the liquid has dripped down. There's very little left in the funnel. I'm going to shake it around a little bit to help this remaining liquid to drip down, and now we're going to quickly proceed to washing. So if you look in your procedure, you will see that you're recommended to get about 20 milliliters of a substance called ammonium nitrate. Ammonium nitrate is the solution we're going to use to wash our precipitate. You might say, why are we washing? The answer to this, we need to wash our precipitate to get rid of as much chloride ion as possible. Remember, we were adding quite a bit of barium chloride. We needed barium ion, but chloride is also part of that substance. And we also had some HCl added earlier. All that chloride may be present in the precipitate, and it will negatively affect the mass of the precipitate, meaning it will make it greater than it should have been. So the goal of washing is to wash out as much chloride as possible. So what I'm going to do now that my filtration is complete, I'm going to place a clean beaker underneath the funnel here, like this. And now I'm going to start adding my ammonium nitrate. I have about 20 milliliters here in a graduated cylinder, but I'm not going to add all 20 at the same time. What I'm going to do is I'm going to use smaller portions of about 5 milliliters each. So I'm going to do at least 4 washings. So as you can see, I'm down to about 15 milliliters, and I'm letting my wash drip down into the beaker. Now, please direct your attention to the board. So I'd like to reiterate that washing solution is ammonium nitrate, 1% aqueous, and the goal of the washing is to remove chloride ions. Now, if I'm removing my chloride ions from the precipitate, the chloride ions should end up in the washing here. How can we test to see if there is chloride in this washing? The answer is a solution of silver nitrate, AgNO3. So this solution of silver nitrate in water dissociates and produces silver ion and nitrate ion. So silver ion that's in silver nitrate, if we add a couple of drops of silver nitrate to the washing in the beaker, silver ions from silver nitrate would react with chloride ions that we're trying to wash out from our precipitate, turning into silver chloride, which is a white solid, which should make our washing cloudy. So if washing turns cloudy when I add silver nitrate, it basically tells me that there's quite a bit of chloride in the washing, which has come from the precipitate we're trying to wash. So let's take a look and see. I'm going to add, this is silver nitrate. So I'm going to add a couple of drops of silver nitrate here. And you can see the washing does indeed become very cloudy. What does this tell me, this white cloudiness in my washing? It's telling me that yes, indeed, there is quite a bit of chloride that's present in the precipitate that I am washing out. In your procedure, it suggests that after each washing, you would test the washing with silver nitrate to see if it would turn cloudy. Now, ideally, after a certain number of washings, you would add silver nitrate to the washing. It would not turn cloudy, indicating you washed out all the chloride. So we'll see if this does happen. I kind of doubt that it will, but we can see. So I'm going to pour this washing out, and then I'm going to set the beaker back down, and I'm going to add another 5 milliliter portion of my washing solution. Going to let it drip down. now we can test again, and my guess is it will probably still be cloudy because there's quite a bit of chloride. Yep, you can see I only added 1 drop and it's turning the precipitate very cloudy, or the solution rather, excuse me, very cloudy. So in the laboratory, if you were doing this, I would have recommended that you only wash your precipitate maximum of 5 times. And even if you do that, even after the 5th washing, you may still see some of that cloudiness develop when silver nitrate is added. However, estimates show that at this point, after 5 washings, you would have removed roughly 90% of all the chloride. So we are doing our job. We're getting rid of as much chloride as we possibly can. We're going to stop the video now, and then we're going to continue later with burning the filter paper.